Yours legs bent.
I did that.
I got that. Yeah, I also got. I'm as smart as an oil. Take that.
You ever doing recording?
Yeah. I'm as smart as an oil. Why? I got a 34. I think that's what people got. You have to say,
I don't think that rule with C pluses gets stickers.
it's like, no.
Years on.
We played it.
Oh, wait, yeah.
I think
Oh, I think I wanted the second one.
Oh.
Wait, I didn't get one of the good ones.
So it's
I got the
because
one after the round one.
it's because you're almost nothing.
what are you doing? I was like,
Yeah, I poured the key.
That's Monopoly to get in Monopoly. Isn't it? You have to get
I don't know how to pronounce that, so I'm gonna say it. Brahagapta. Oh, yeah. Brahagapta.
it was only for you. This is kind of sex crime time. My least favorite time of the year. I just taught Caitlin how to knock someone out. Don't use that. Wait. Why were you being a slave and turning around?
What? You guys are awesome nerds. I got 0.5 editing.
Wait. If you're a nerd, doesn't that mean you did worse than that?
No, I said you guys are all
They
nerds.
pushed your best.
Into.
So what does that mean? They did better than you?
I don't know.
Right
up on my head.
I know, I see it. My grade Hey, yo, man, come here.
Dude, the most fun thing I did, and like I had a school party, we had like a men tournament, and that's like, I didn't watch the game, but I think he was
I got a C plus. What did you get?
mainly
Imagine not getting a C.
That's
Yeah, that's what that is.
Oh, I think that camera on.
How do you use the big one?
I spent like $10 this week.
Yeah.
Bro, I bought it.
Yeah, that's even something like it. And I was
I
like
had
a
like
little bit.
15
Yeah. Sometimes it's still like this.
It's so fun. I don't know why I couldn't buy it.
I'll play for like
I got that one.
and then not play for a year.
Yeah, that's so I did that. Every time I got one, that's like, it's like it's always but it's a grind.
Great.
Obama
needs family.
Okay, guys, it's time. Alright, it's time. So, you guys are the answer to your very problem already. I'm gonna go over with you. Okay.
Mr. Ayers, my iPad is like randomly started updating.
Try new when you can. Okay. All right. So, who exactly answered for the first one? What value to the what value there? The question mark equals get an expression equal to 16, Eliza.
4.
4 is correct. Good job. How about number 2? What value for the question mark? Tony?
3.
Yep. How about number 3? What value for the question mark? Brandon? 2. Good. Anybody got number 4? Eric? That's right. And I'll show you why later on in this unit. We are in the final unit. Okay. Not the final topic, we're in the final unit. Okay. We're in this unit for the rest of the semester.
we finish this early, what do we do?
Well, see, here's the thing. You have 6 topics in this unit. Okay? Which one? A little bit more down to earth? Yeah. So the first one is exponents. We were talking about exponents when I start that unit today. Okay? The nice thing is that I have notes for you already typed out, so you don't have to worry about thinking a lot of your own notes. Okay? We're going to do some activities, though. Okay? As we go along, try to get some of this stuff formulated and whatever. Okay, so like we did before. So we've got a lot of group work to do today, and everybody is here. So this is going to be wonderful to do this today. Great. And we'll put the dice in, play me a little bit later, and everything else. Good. Wonderful. Everybody's favorite. So let's get going. Go ahead and download your notes, guys. Okay, put them in Notability for me. I'll duplicate my notes right here. I'll get these ready. And then I'm just going to do a little side note here. Excuse me. And we'll just have a little, we'll just teach, I guess, some activities with this note here. Okay. All right. So everybody ready to go? Okay. So without using any external resources except for the other brains in your group, that's all you can use is the other 3 brains in your group. Okay. No calculators even. Okay. Only the calculators and the brains of your other people in your group. That's it. Okay. The free calculators. Okay. Yeah, you can write stuff down on there. You just can't use your calculator. Okay, so I have a question for you guys, okay? 2 to the 7th times 2 to the 5th equals what? Okay? Now, here's the deal. I want this answer in what we call exponential form. Does anybody know what exponential form is? Emily? Yep. It's a large number, what you call a base, raised to a small number, what you call an exponent. We'll put this all on your note page in just a minute, okay? But I want it like a number to a power, okay? That's the format that I want for your answers, okay? So I'm going to get an answer from each group, and then we're going to go over them. So talk about it for a minute or so, and come up with one group answer. I will tell you that I'm going to listen to Eliza, Sadie, Mason, and Emily. They're going to be the designated spokespeople for the group for this round. Go. Be prepared to explain your reasoning.
Yeah, that's pretty sure that's what it makes sense.
I think that's what start with the same page.
We should add 7
No calculators right now.
Well, maybe we like back it out and see if I'm right.
One consensus answer. One majority rules answer. 30 seconds, please.
No, they're right.
Let me 0. I'm getting 2 to the first power.
That's beautiful, yeah.
Are you ready? Okay, we're going to start with the red group. Eliza's going to tell me the red group answer.
2 to the 12th power.
2 to the 12th power. Okay? 2 to the 12th power. Here we go. Okay, Emily? 2 to the 12th power is for the blue group also. Okay, Mason? You also have 2 to the 12th power. Okay, Sadie? Well, this is exciting now, isn't it? Okay, so let's make it a little more exciting, shall we? I'm going to put 2 answers up here. Because what? No. See, it's not cheating when you get to make the rules. See. Okay. Loosely. You're exactly right. Loose dictatorship. Yeah. Loose dictatorship. Yes. Okay. That's the mantra in this classroom. Okay.
Well, it couldn't be a
Or the facade of a democracy. How's that? You like that better? No. Okay. Okay. So here are the two answers I want you guys to consider. I could really put another one up there too. Why not? Let's do 3. How's that? Okay. So at least one of I know. See, I changed the rules again. Okay. At least one of those answers is the correct answer. Talk to your mates. If you want to keep your answer or change to a different answer, go. 30 seconds. Be prepared to explain your stance.
I think we should keep our answers to figure out like something you just have to do something 2 times 2 times 2.
I can see 4 toasts or 4.
Yeah, I can see
How did you get that number by sure?
Yeah.
But I think we should.
You did that all with the existence of this calculator here in your head. You don't use any other electronic calculator means. Very well. Very well. I did not find any wrong with it.
Why? Nothing with the other way.
I don't think it was a 4 different number. Since with exponents, it's still just 2 times 2.
Okay. Going back. Red group. Keeping or changing? They're keeping. Emily? Keeping. Mason? You're going to change the 4 to the 12th power. Okay. Sadie? They're going to keep. I got somebody to change, huh? Why does that necessarily insinuate that my answers are all 3 incorrect? Well, you know at least 2 of them are, right? Okay. Yeah, I got them to switch. I convinced them. Okay? I convinced them. That's all I meant.
Sure, that's what you
Okay, so how did you get to the 12? Okay? How did you get to the 12? Okay, Eliza?
Well, first off, the easy way is to add them together.
Okay.
With exponents, it's basically 2 times 2 times 2 to however many to the 7th power for the first one.
Okay.
To the 5th power, if you're just timesing those 2 together, you just add the amount of times you timesed it by 2.
Okay.
That sounds really weird.
No, that sounds okay. That sounds good. Okay. Emily? Which you're not supposed to be using at the moment. I did say to download them. I also said the only thing you're allowed to use is your brains.
That was an afterthought after I got my answer.
Okay.
My mom told me this last week and I don't remember.
Huh?
I wasn't paying attention.
Okay. So here's the thing, guys. I think we have 7 of these rule properties that we need to make sure we know how to do, and we need to prove them. Okay. So the way we're going to prove these is by expanding out the expression. We know how to expand an expression written as a power. This is how it's called a power. Okay. We'll do that terminology in just a second. We just write out how many times multiplying the 2 in this case by the exponent. Okay. So the first one, I'm going to highlight this one here in red. We'll highlight this one here, and I guess we'll do green. Okay. So I have 2 times 2 times 2 times 2 times 2 times 2 times 2. Then I have 2 times 2 times 2 times 2 times 2. How many 2's? 12. So, whoops, not 12. 2. Okay? It's 2 to the 12th power. So you guys are correct. But the reason why this is allowed to happen when you're able to add those together and get the right exponent on your base is because it expands that way. That's the reason why. Okay. So, I'm a big guy about, I'm real big about making sure you understand why we can do what we can do, not just what we can do to solve problems, but why can we do it? Why is it allowed? Okay. Why is it allowed? Because if you expand out that expression, you get 12 base 2s. Okay. So then that expression becomes 2 to the 12th power. So when you multiply powers that have the same base, you add the exponents together. That's the rule. Is everybody okay with that? Good. Let's go to our notes now and put that in. Okay. So before we do that, though, let's go up here. I'm just going to appear to the margin, and we're going to diagram one of these here real quick for everybody. So I have this expression right here. This is called your base, remember? This is called your exponent. And the whole thing is called a power. Everybody good with that? No, that's, you might hear me say like 2 to the 12th power, okay? We're not always going to say like the power, 2 to the 12th. I'm going to say 2 to the 12th, I'll say 2 to the 12th power. We don't always say power, okay? But the whole expression there is called formally called a power, all right? So, if you go down here to property 1, this is exactly what we just proved to be true. For any non-zero number a, and rational numbers m and n, a to the m times a to the n equals a to what power? Raise your hand, please, if you think you have an answer here. We just proved this. Wyatt? A to the m plus n. Very good. So m plus n goes in the blank. Okay? Basically, when you're multiplying powers and they have the same bases, you add the exponents together. That's all this is saying. Okay? Now, here's something that might be a little bit different from when you guys were in pre-algebra last year, for most of you. These rules also work with variable bases. And I don't think last year you were introduced to variable bases. And if you were, you probably were just lightly introduced to it. Well, now they're going to become a staple in this class. Okay? But the good news is that it doesn't matter what the base is. It can be a number, it can be a variable. The rules apply the same way. Okay? So that's a plus for us. That's a benefit. Okay? Let's do some examples. So example 1 over here is 3 to the 4th times 3 to the negative 2. All right? So what do I do with the 4 and the negative 2, class? I'm going to add them together, and 4 plus negative 2 is what, class? 2. And 3 squared becomes what number? Don't say 6. What number is it? 9. Very good. Okay. If I had $1 for every time somebody told me 3 squared was 6, I could have retired last year. Okay. So here's the thing also regarding final answers. Usually in exponential form, unless it is a value that we know, like the perfect square of easily, like 3 squared, we know that's 9. Okay? So perfect squares up to 12, you could probably simplify. Perfect cubes, maybe up to 3, 4, 5, you could probably simplify those too. Look and follow the directions. If it says leave your answer in exponential form, then leave your answer in exponential form. Okay? What's exponential form? A base raised to an exponent. Everybody good with that? Good. Number 2, b to the 11th times b squared is b to the 11 plus 2, which is b to what exponent, kids? Excellent. Everybody okay with that? You just have gotten through property 1. 6 more to go. Okay. Any questions on property 1? Individually, these properties are pretty easy to follow along with. The issues are going to become when you have the simplified expressions that incorporate multiple properties at the same time. Okay? And we're going to be getting there maybe as early as next Tuesday or next Wednesday, because you guys aren't here. We're not here on Monday. So it's coming quick. I suspect another assessment over this stuff by the end of the month. Okay? We'll kind of see how it goes. If it's not at the end of the month, it'll be at the very beginning of next month. Okay? Probably 2 more assessments, maybe 3 before we go on spring break even. That's a ways away though. Okay? All right. Let's go on to the next little challenge I have for everybody. Okay? I'm going to erase this or bring up another challenge here. Same rules. Okay? Only your brains. No notes. I won't mention anybody's names. Okay. ER knows what's going on. Okay, so here's the next one. Try this one out. So let's say I have, what if I have 5 to the 10th divided by 5 to the 3rd? Okay. Okay. Discuss that with the group. Come up with one group answer. Okay. This time we'll have Reed, Tony, Wyatt, and Caitlin report out for the groups. Okay. Go.
Not really supposed to throw headlocks, but I did it anyways because the opportunity presented itself.
Had to take it.
Had to take the opportunity, huh? So you really not supposed to lock hands, right?
From the top, if you're standing there, you come off your hands.
Gotcha. I forget all the rules. I don't follow. Okay, you guys ready to go?
Yes.
Okay, we will this time start with the green group. So Caitlin, what's your answer for the green group? 5 to the 7th power. Okay. Wyatt? 5 to the 7th power. Okay. I sense a trend. Reed? Okay. My 4th sense here is signing that Tony's probably going to say the same thing. 5 to the 7th power. Well, you know me. Okay. Somebody's right. Who's right? Talk about it.
I mean, technically, it's 10 over 9.
Why would it be?
Yeah.
That'd be
Well, I mean,
Yeah, I don't see that being a
technically,
possibility. I don't see that as something a possibility at all because if you were to divide the first number, you would also divide the second number. Right, you have to-
No, on a paper.
the base, you have to divide that.
Okay. 5, 4, 3, 2, 1, 0. Thank you very much. We'll go back to Caitlin. I guess you're not going to change. No change. Wyatt?
We will not change.
No change. Reed? No change. No change. Okay. Again, by now you should know that you don't need to have a calculator for these. If you expand it out, follow the rules. You can get the right answer every single time. Okay? Let's do that here right now and see what happens. Because remember, we prove all these properties with expansion. So if it expands out to be what the answer is, then that's how to be able to incorporate the property. So we have 5 times 5 times 5 times 5. 5 times 5 times 5 times 5 times 5. Is that 10? Nope, that's 9. I count 9. Is that right? Name one more? One more. Okay, there we go. Okay, and then we have 5 times 5 times 5 on the bottom. What's 5 divided by 5? 1. Okay. When you multiply by 1, you get what you started with, correct? Okay, so that just cancels out, correct? So I have 3 5s on bottom that are canceled with 3 5s on top, like so. How many 5s are left over? 5 to the 7th power. Okay. Now, the easy way to get that from just looking at these exponents is to subtract them. Very good. Okay. I think you figured it out. When you multiply bases, you add the exponents. When you divide bases, you subtract them. Very good. Okay. And now you know why. You know how it works. Okay. Let's go to the notes. Get that one filled in. Cross that one off the list. Okay. So, for any non-zero number a and rational numbers m and n, a to the m divided by a to the n equals what? A to the what? Help me. Sadie? M minus n. Very good. Everybody okay with that so far? By doing the properties this way, it allows us to account for both numerical and variable bases. That's why we're making this more of a generic property statement here. Okay. Number 1, here in your example, 5 to the 6th over 5 to the 4th. It becomes 5 to what exponent? 6 minus 4. 6 minus 4 is, and 5 squared is 10. Oh, 25. Okay. Just if anybody was paying attention or not, you know. All right. Now, you guys work number 2 on your own. Go. Emily, did I ever hear you say you're on property number 6? Why?
You think you're better than us just because you're better than us?
She's using her notes to figure out the answer.
I don't think she's using her notes.
We're supposed to be using our brains.
Well, last time I checked, we were on property number 2, example 2. Okay.
You just got
All right. Okay. All right. Let me see. Blake. H to what power, buddy? H to the 19th power. Very good. Your double negative does indeed become a positive. Yep. You got to watch for that. It's one of those little things that could make or break a problem for you. Okay, because that gets overlooked a lot when you're in the zone of trying to simplify a larger, more complicated problem.
They have negative numbers like in second grade.
Baby. Okay, so far, 2 properties down. Are we okay with both of them? Okay, good. So individually, these are not that difficult, I don't think. Again, the fun's going to be when you have to combine these together to solve larger problems. Okay? So we get through all the properties, we're going to spend a lot more of our time really going into those more multi-step problems that we're going to see. Okay, Eliza?
We're going to figure out how to factor out exponents.
In a way, yes, but not necessarily right now. Okay? We are going to be doing some factoring this semester. All right, ready for the next example, guys? Well, we're going to do one anyway. It was a rhetorical question. Just because I'm not erasing right. Okay, ready to go? Next one. Here we go. Ready? I want us to do 7 squared all to the 4th power. What's that equal? Okay. Groups aside. We'll talk to RJ, Blake, Toby, and Brandon this time. Okay? Talk about it. Figure it out. Go.
Once that's done, then you go to the 4th power. It's not going to be 7 times 7 to the 4th power after 7 times 7. Yeah. This could be the one time we actually
Yeah.
I got so I agree, right? So I completed this class for Yay, Team Strawberry for the win.
Probably not good.
I've been saying Team Strawberry for the last month and no one's noticed.
Okay, 5, 4, 3, 2. I have a feeling everybody has something that's locked in. Good. We're going to start with Blake's group. Blake, what's your answer back to the blue group?
7 to the 8th power.
7 to the 8th power. Okay, Brandon? Green group? Toby, yellow group? Okay, RJ, red group. Okay, so we have these answers. We have 7 to the 8th, 7 to the 8th, 7 to the 8th, 7 to the 8th. I have this.
What?
Okay? Keep it or change it. Go.
Technically, it's all the same thing. Where is it? Yeah, technically it's about the same thing. There's 2 extra that we don't know. Wait.
Okay.
No, I think we have to keep it because each one would be.
All right, here we go. 5, 4, 3, 2, 1, 0. I'm going to make this real simple. Anybody changing their mind?
No.
Good. Okay. Now, as it turns out, though, we're all correct.
Yeah.
Okay? Because, even me, here's the deal. Okay? If you follow the order of operations, you take care of exponents inside parentheses first. So 7 squared is 49, you get 49 to the 4th power. However, you guys probably figured another rule, didn't you? Did you guys remember a rule from last year?
Yeah.
Okay. This is called raising a power to a power. So when you raise a power to another power, what do you do with the exponents? Multiply. Do you know why you multiply? Where you show why you multiply. Oh, here's where I get to do my job. Hold on a second. Let me show you how this works. Okay. Again, we're going to do what? We're going to expand the expression out. Okay. Check this out. What's getting raised? 7 squared, right? How many times do you multiply 7 squared by itself? 4 times. So this becomes 7 squared times 7 squared times 7 squared times 7 squared. You follow property 1. When you multiply bases, what do you do with the exponents? You add them. 2 plus 2 plus 2 plus 2. 7 to the 8th power. That's how it works. That's why it works. Okay? Now you see, like I said, I think it's important that you know what to do, but I also know I think it's important you know why you can do it. Okay? And this is why this is legit mathematics. It's not something that we just are driven up and saying this is why you do it. This is legit mathematics. Okay? This is why it works. Okay? Any questions on this one? Okay, I think we're going to fill in our property 3 information, and we're going to call it quits today. Okay, and then we'll fill in the rest of this hopefully on Friday. All right. So we'll get to property 3, and then the next time we'll try to fill in 4, 5, 6, and 7 because 4 and 5 I think are pretty quick. All right. So property 3, a to the m times a to the n is a to what power? A to the m all to the m power, I should say, is a to what power? Brandon, thanks for raising your hand. M times n. Yes. Okay. Good job. All right. So, example 1. 13 to the 3rd all to the 5th power. 13 to the 3 times what, class? 4 product of. Very good. That's one where you can leave it as 13 to the 15th. I don't expect you to, on your calculator, do 13 times itself 15 times. That's silly. Okay? You leave that as is. Now, that's like I said again, if it's a simple like little square, like 8 squared, you should know is 64. Okay, then you can probably write it out as 64. 2 to the third, you should know is 8. 3 to the third, you should know is 27. Okay, 2 to the fourth, you even know is 16. That's about it. Okay, so squares, little cubes. Okay, you should be able to expand out. Everything else, leave in exponential form. Okay, everybody good with that? Good. All right, last one. You figure it out. Okay, Alex, what'd you get? Nothing yet. Okay, that's fine. I'm in no hurry. P to the 16th power. Very good. Positive 16. You know what throws everybody off on these problems every single time, really, are the negative signs. You treat those with courtesy and respect and treat them and handle them correctly, you'll be okay with these problems, okay? Watch those negative signs. They always throw people off, okay? So those negative signs can be your worst nightmare in this topic. Don't take them lightly, all right? And with that, we're going to quit for today.